Hey there, Mr. Caldwell here. Wanting to give you guys a little bit of help with your limiting reactant lab, um, both parts 1 and 2. So, jumping right into it here, one of the issues is folks are having trouble with the last page, page 5 of the limiting reactant lab, part 1. And so I'm not going to give everything away, but maybe I give you just a little bit of a nudge here to help you. So let's go ahead and just look at this. And so it says, let's go ahead and calculate the mass of copper 2 hydroxide produced from the mass of copper 2 nitrate. Use the mass from the data table in part 1. So, so we literally just have to read it carefully. So we go back to the data table from part 1, and we'll refer back to that reaction here in a minute. But you should have some raw data that tells you exactly how much copper 2 nitrate you're starting out with. So you're going to start out with the number of grams of copper 2 nitrate, CuNO32, and you know that you have to do whatever stoichiometry is necessary to convert that into copper 2 hydroxide. So we want that in grams of our copper 2 hydroxide, CuOH2. You're going to make sure to do the appropriate stoichiometry using the balanced chemical equation, and you're going to get some value. All right. Then you're going to do the exact same thing on this side, but realizing that this reaction required 2 reactants. It was not only the copper nitrate, but it was also the sodium hydroxide. So we want to think about, all right, if the reaction was driven by the copper nitrate, it makes this amount of copper hydroxide. If, on the other hand, it was driven by Z amount of my sodium hydroxide, which, sorry, I'm off camera, my amount of sodium hydroxide, right? Go ahead and figure out how many grams of copper hydroxide that makes. And you have to remember, this is one of those limiting and excess reactant problems. You have to remember which one of these you're going to choose. Do we choose the bigger or the smaller value, right? And then once we decide on who the smaller value is, then we go back and we're able to decide, well, was it the NaOH or the CuNO32 that was the limiting reactant? The limiting reactant is always going to be creating the smaller quantity of product because that's what you're going to actually be able to make. So hopefully that gives you at least a little bit of a nudge for that part. And then obviously, if I pick one of them as the limiting reactant, either the NaOH or the CuNO32, then the other one would have to be the excess reactant, which we'll be looking at here in just a minute. So part 2, all right? Part 2 of part 1, and yes, I realize that does get a little confusing, says to go ahead and do the stoichiometry to figure out how many grams of copper 2 oxide should we get, right? Grams of CuO from our theoretical quantity of copper hydroxide from part 1 above. So remember that up here at the top, our theoretical yield should have been highlighted in green, right? And that would be the amount that we would have actually, theoretically, we should have made in a perfect world, right? So whatever you highlighted in green up here, that's going to be the beginning point for your problem down here. So I'm not going to give that away, but you're obviously going to be doing some number of grams of CuOH2. Right, so that's part 1, and hopefully that helps you all in getting that done. Now let's shift gears and look at part 2. Right, part 2 builds on the work from part 1. Right, and so again, we've just determined who the limiting reactant was on the previous page. So we now know who the excess reactant is for part 1 of the part 1 lab. This next set of questions has us go through the process of determining the amount of excess reactant left over. So it says, using the limiting reactant mass, all right, we're going to convert that limiting reactant into excess reactant. So I'm going to take, going back to the part 1 of my lab, all right, one of these is my limiting reactant. That value, either the Y grams of copper nitrate or the Z grams of sodium hydroxide, I'm going to take one of those. I'm going to take the grams of my limiting reactant, and I'm going to convert that into whatever my excess reactant is, okay? I'm intentionally not telling you which one is which because that's the thinking I want you to do, okay? But we already decided who the excess reactant was here because we'd already decided who the limiting reactant was here. So then, what do we do at that point? Once we figure out the number of grams of limiting reactant and we turned it into number of grams of excess reactant, to determine the amount of excess reactant left over, we're going to take the number of grams of excess reactant from the lab, all right, that's from part 1, and we're going to subtract this value from above. So we'll just pull that value down, and that's going to give us the amount of excess reactant left over. And that's ultimately what this process is all about, okay? Now, since the calculations that I'm seeing the most trouble with, all right, I'm going to go ahead and move over to the last page of part 2, right? Percent yield calculation, remembering that percent yield is experimental, which is also known as actual yield over theoretical yield. And this is for the copper 2 oxide, which again, a little confusing, but was the part 2 part of part 1. Excuse me for that. So listen, I'm going to have to go in here and figure out how much copper 2 oxide did I actually get from the lab and how much should I have gotten. I can tell you that the should number, that's coming from the very bottom of this last page of part 1. This is how much copper oxide you should have made right here, right? And how much you actually did made, well, that you did make, you're going to have to look that up in your data tables there. All right, then you have to do a little bit of thinking. And then when we come down here to the very last, all right, guys, you're going to balance these equations out, right? You're going to then take each of the quantities given in each of the problems, and you're going to do the stoichiometry to turn it into whatever it's being asked to turn it into, all right? Then, and this is the same for each of these 3 problems, then you have to take, and just as we did a moment ago, to determine how many grams of excess is left over, right? You take your grams or your amount of limiting reactant, and remember, each of these 2 values are going to give you 2 numbers. Right? They're going to give you a amount of, in this case, NH3. You're going to choose the appropriate one, shall we say. It's either the bigger or the smaller. And then once you choose that, you go back to whoever made that. And you say that one has to be the the limiting reactant, because that's what's controlling the amount of reaction that occurs. So this process is you turn your limiting reactant into how much excess reactant that would be. And then you take that amount of excess reactant and subtract it from, one of these is excess, you subtract that value from whichever one of these is the excess reactant. I hope that this video helps you. I didn't want to do the work for you because you are the one that needs to do the work. But I do hope that it helps. Okay, hopefully everyone has a great day, and I will catch up with you guys in class soon enough. Bye-bye.